sits next to your router. To talk to the outside world. Now all this communication from the individual, in this case, for the Q bulb, this is all wireless. You couldn't really have a wire going from the light bulb all the way across your house to the router. So this uses wireless communication, and the type of wireless it uses is something called Zigbee. And we'll look at that later as well for their communication. Now, Zigbee can only communicate over a certain distance, so if you get one that's a bit far away, that can't make the full communication, that can talk to one in between, which can then pass the message on. So that particular organisation is what we refer to as a mesh network. A mesh network, and you don't have to talk just through one particular centralised node in what we call a star network to get there. So you can have one light bulb too far away, and then each one acts as a relay. A relay, like a messenger, somebody who passes on messages from one to another. And I gave the analogy of perhaps if we had another class, everybody's listening in here, if the other class wanted to listen in, I'd have to have some way of getting the message to them. And not a very good way, but one way I could do it is just ask one of the people in the class to say, look, every time I say something, can you run next door and tell them that message? And then come back again. So that one person relays the message on to extend the communication. And there may be somebody in that class who's passing it on again, somewhere to relay it. But what that means is that each one of these has to be able to not only send their data out, but also listen for it. I've asked my friend here to relay the messages. She can't just sort of lean back and half fall asleep for a bit and drift off and just say, oh yes, he's still talking on and on. She has to listen to everything I say and then do something extra, and that takes a little bit more energy. This actually does come with a development kit as well. In this case, there's this site. The developer's got meetyou.com. So if you want to learn how to write your own applications for it, yep, they supply you with a programming interface, API, application programming interface. And lots of demonstrations about how to get started on it, how the data is transmitted, how you set up accounts for it, so how you might write your own application to control lights. And then what you do to control they'll show you how to control the lights, but the reason that you're controlling the lights will be up to your application. Is it because you've got some music app that's then turning aspects of that music into flashing lights? Now, there is a reason that I'm sort of pointing some of these out. That's very relevant to what you'd be doing in the assignment. I'd want you to be able to do a diagram of different types of node and think about these sorts of things. How does a node communicate with each other? What sort of topology is it? Mesh, star? Is there a hub? Is it wireless communication? Is there a development kit for it? Because they don't all work the same way. Each one has got different capabilities to offer you. But in general, we've got this. I've taken that and just put some labels on it really, therefore, for the Phillips Hue. But it's the same idea. Lots of nodes about one special node acting as some sort of link to the internet. Here, this is what we've got with the hub. It's linked to the internet. It's connected to a router. It may be that perhaps for an external one, you might decide that the hub and the router is just all in one box. But it's got two jobs to get out to the internet. One is a local communication, and then how to then translate that into an internet, a more worldwide communication to it. So, this communication between a node and its sensors is only one part to it. You've got the communication between the different nodes on the network. They may not be in radio range. Typically the nodes are wireless, although in the examples we've been using in the labs, all your nodes have sort of wired connections, slider going through this, and then that plugs in through USB into your PC. That was your sensor. Your PC was your actual node to get into it. And sometimes the sensors are wired in, and sometimes they're not. But in this case, all ours were wired. But the individual node may not be in range of being able to connect to the internet. And again, with the classroom one that we had in the lab, we didn't really have that situation because individual desktop PCs had a wired connection. And it was wired all the way for it. But where we've got multiple nodes that aren't always directly connected in the lab, that was the situation. All ours were directly wired into our hub. We didn't have the situation of having to bounce through, which is where they may be out of range. So we need to think about hubs being out of, individual nodes being out of range, out of radio range for it, and having this distributed system. A distributed sort of network system for it. And once you've got this distributed system, this wireless network, there's different ways of connecting them together. In general, we refer to them as a wireless sensor network. All of them being able to sort of communicate with it. But we have other special types of them for vehicle networks, ones that use different technologies like Bluetooth. There's various ways of connecting this multi-hop wireless network, and multi-hop it has to go bounce, bounce, bounce before it gets to its final destination. Main concern is, does it work well? Is it an efficient system? And I gave this example of having a lecture going on in the other room, and I asked my friend here to keep going back and pass that communication through. It will work, it's not very efficient. Every time I pass a message here, it has to get up, walk into the next classroom, relay the message on. It might take 60 seconds, so there'll be a 60-second delay between me saying something and next door actually picking it up. Whereas a better way would be to have this microphone system linked next door. There, the time taken for the message to get from here to next door is as fast as electricity to get through. So a lot faster, a lot more efficient to do. And it's these sorts of things, performance, reliability, is the transmission through this microphone a better way of doing it in terms of reliability to get next door than my friend here. I'll trust my friend here, I think. Microphones can break down as well. And as you get this, we may have what happens when a new one appears or disappears. So inside this network, I've got my home network, and these are all, say, my lights. They're all in different rooms. Everything's working okay, I can communicate okay with them, the lights come on, they work with my app. And then I buy a new one. I buy a new bulb. How does that join the network? Rather like when you come into a new Wi-Fi network. If you've been there before, it recognises you, remembers you. But the first time you enter a new wireless network, you get your phone out, scan for available Wi-Fi networks. You see a list of them coming down, you select one. If you've been there before, it's probably remembered your password, but generally there's a password to put in, and you make that connection. So a new one here does effectively the same sort of thing. It has to find the access point.